Hi, a very good day to all, and welcome to another session of virtual classes of Science. And I am Shabu Subramanian, signing in to discuss the questions on equations of motion, which is a part of motion in a straight line, or we can say kinematics of one-dimensional motion. And this session is very relevant for you when you are preparing for your board exam as well as entrance exams. So I am just taking the part in terms of the crash program only, so I will be going through the equations in a quick manner, and I will stress whenever it is described or to be described. Okay. So here is equations of motion. I hope all these will be very much known to you all. These are the three famous equations of motion which relates velocity, position and time and acceleration. And all of you have to remember in your mind that all these are relevant or applicable only under the condition that when the acceleration of the particle is a constant. So all these three equations we must have done in different manners while we have done the theoretical aspects of kinematics of one dimension of a particle. We must have derived this one using calculus, maybe using graphs or algebra. And these equations will be there in your mind always. Okay, so I am taking it as granted and I am going to discuss some more equations which are related to these concepts. And out of that, the first one which I want to discuss is nothing but the concept of average velocity. The concept of average velocity, or the equations that we need to learn in order to solve the problems. Average velocity. And I can tell you that this has got three different modes or three different threads. The first one is, of course, which is related to a constantly accelerated particle. It is a particle when it is accelerated with a constant acceleration. The average velocity has got the expression u plus v divided by 2, where u and v has got its usual meaning, that is initial and final velocities. And this is applicable only when it is mentioned that the acceleration of the particle is constant and it is given in the problem. But what if that is not given, or nothing is mentioned about acceleration? No, we don't know specifically about acceleration. We don't know anything specific about acceleration. There can be occasions in which questions can be asked in that manner, and there are two possibilities for that. One is, or we can define this one in case 1 and case 2 cases. Case 1 and case 2, that you have different intervals or specific intervals mentioned, in which the first one is a case of equal time intervals. Equal time intervals. That is, you have different time intervals T1, T2, T3, T4, or delta T1, delta T2, delta T3, like that, and in which the particle has got velocities V1, V2, etc. up to Vn. Time intervals are equal, but if velocities are different, we can guess that displacements will be different. For that, the expression for the average velocity is v1 plus v2 up to vn whole divided by n. This, you know that this expression in mathematics is known as an arithmetic expression, or that we call it as what? The arithmetic mean values. We call it as arithmetic mean values. Okay. So, if there are only two intervals, suppose there are only two intervals, say v1 and v2, expression becomes very simple, that is v1 plus v2 divided by 2. And into the second case, when, say like we have discussed equal time intervals, now same like we can have equal displacements. For example, maybe particle is going, a car is covering half of its initial distance with a particular speed, and second half. Say first 100 kilometer with a particular speed and second 100 kilometer with a different speed. That can be possible. We can have different velocities for that. Say v1 equal to vn. That is first half with 50 km per hour, second half with 60 km per hour. You may have to find the average velocity. In that case, definitely the time intervals will be different, and we get the average velocity expression as n divided by 1 by v1 plus 1 by v2 up to 1 by vn. You can refer into my session which I have done with the concepts of average velocity. In detail, I have shown how the expressions can be derived. This is called as harmonic mean of velocities, or this type of expression in math is known as harmonic mean value. Obviously, if there are two intervals only, say v1 and v2, expression for v average turns to be 2 over 1 by v1 plus 1 by v2. Solving will get 2 v1 v2 divided by v1 plus v2. So you can note down, we have seen three different expressions for average velocity. One is related to the equations of motion when the acceleration is constant. Average is initial value of velocity plus final value divided by 2. Second is when there is nothing specified about acceleration. We have equal time intervals, average velocity is arithmetic mean of all the velocities. Unequal displacement, average velocity is harmonic mean of all the velocities. So that is a concept that should be known to start with questions of crash, which is related to average. With this, along with the constant acceleration, next concept you have to learn is the displacement at nth second of motion. Nth second of motion. That is Sn is equal to u plus a into n minus 1 by 2, or even you may write this one as Sn is equal to u plus a by 2 into 2n minus 1. Some of you must have studied in this manner, and in other textbook it might have written in this form. That is displacement happening at the nth second of motion after start. You can easily derive that from starting from equation S is equal to ut plus half a t square. You have done this one while we have done the concepts of nth second motion and its equations of motion in theory discussion. And that can be easily understood if you have taught the concept like, say 0 to n second after starting from rest, the particle will cover a displacement of Sn is equal to, say, ut, or ut becomes t is nth second, un plus half a n square. And we have to find the displacement in the nth second, so we have to subtract the displacement till n minus 1 second. N minus 1 second, the displacement will be equal to u into n minus 1 plus half a n minus 1 the whole square. This is equation 1 and this is equation 2. 1 minus 2 will give you Sn as the expressions. That is the nth second displacement of the particle. Just one more concept that should be learned along with the equations of motion is the concept of stopping distance. Concept of stopping distance. Or we know that it is the process of stopping a particle. So like if a particle was initially moving with u, if you want to stop it, what you have to do? You have to apply an acceleration in the opposite direction. Or we can say we have to apply brakes on a car, or we have to apply some force against the body which is coming. That is all known as retarding forces. Or this type of acceleration is known as retardation or negative acceleration or deceleration. What will happen for the object? The u will decrease continuously, and ultimately what will happen? It will come to stop. So that will take some time. So the problem is how much distance is required. That distance is known as the stopping distance. In order to analyze that, we know u, we know v, and we know a, and we know s. Use v square is equal to u square plus 2as, 0 equal to u square minus 2as. Why a is negative? We will get s is equal to u square by 2a. So the stopping distance is s is equal to u square by 2a. You can generate two proportionalities. S is proportional to u square and s is proportional to 1 by a. This will be useful for doing different kind of questions. We have the question number 1, in which what is given here is the average velocity of a body moving with uniform acceleration traveling a distance of 3.06 meter is 0.34 meter per second. The change in velocity of the body during this is 0.18 meter per second. Question is its uniform acceleration. Problem is to find the uniform acceleration. Start from the question. What is to be found? Acceleration. What is acceleration? We know the acceleration is equal to delta v divided by delta t. Look at the problem. Delta v is already given. That is change in velocity is 0.18. 0.18 divided by delta t. So delta t is unknown. For that we can refer into the concept of average velocity. What is given in that problem? Average velocity when it covers a distance is given as 0.34. What is average velocity? That is simply defined as total displacement divided by total time. We have average velocity 0.34 is equal to 3.06 divided by delta t. So we can obtain delta t from here. What is delta t? It is 3.06 divided by 0.34, which is equal to 9 seconds. Substitute into the other, it becomes a is equal to 0.18 divided by 9, that is nothing but 0.02 meter per second square. That's our answer. So we have the second question, in which a data table is given that gives the position of the object at different times. We have time given in seconds and x given in distance given in position given at meters. At 0 it is at -2, at 1 it is at 0, at 2 seconds it is at 6, at 3 seconds it is at 16. The question is, which of the following describe the motion correctly? Option A is uniform accelerated. Option B is uniform decelerated. Option C is non-uniform accelerated. And option D is data insufficient. Let us determine whether it is uniform or non-uniform. Uniform means what? Uniform means the magnitude of the velocity should be constant, or we know that uniform explains the speed of the particle have to be constant. On non-uniform, what is non-uniform? The speed is varying, or we can say magnitude of velocity is changing. And what is uniform velocity? Uniform velocity means magnitude as well as direction have to be constant. So let us check what happens for the magnitude of the velocity. We have different intervals. First interval is from 0 to 1, 0 to 1. Second interval is from 1 to 2. Third interval is from 2 to 3. What is velocity during this? Say x2 minus x1 divided by t2 minus t1. What is x2? 0 is x2 minus of minus 2. What is t2 minus t1? 1 minus 0, that is 1 second. That is minus of minus 2, 2, so value is 2 meter per second. In the first interval, the velocity has got a magnitude of 2 meter per second. Second interval, v is x2 minus x1, that is 6 minus 0 divided by 2 minus 1, still 1, 6 meter per second. That is velocity's magnitude is varying. Let us check in the third interval. V is equal to 16 minus 6 divided by 3 minus 2, that is 10 by 1 or 10 meter per second. Clearly indicates it's a non-uniform motion which is accelerated because velocity is increasing. So it is not decelerated, it is accelerated. Option A is non-uniform accelerated motion. Problem is given like the acceleration of an object starting with 7 meter per second is 4 meter per second square. So acceleration is 4 meter per second square and initial velocity is 7 meter per second. Question is to find a distance covered by the particle in fifth second after the start. Option A is 25, option B is 35, option C is 50 and option D is 85. We need to start with the formula of displacement on the nth second. Displacement on the nth second. We have this one as u plus a into n minus 1 by 2. Problem is to get displacement of the fifth second. U is 7, acceleration is 4 and the displacement happening on the fifth second. So this is the formula. 10 minus 1 is 9 by 2 times 4 plus 7. 18 plus 7. Problem gives the answer of 25 meter. Here it is given the fourth question, like a body starts from rest, ratio of distance travelled in fourth and third second. Problem is still based on the nth second motion. We know nth second displacement is equal to u plus a times n minus 1 by 2. It's given that it is starting from rest, that means u is 0. So our relation turns to be a into n minus 1 by 2. And a for the particle is same at fourth and third second. So we are treating it as a uniform acceleration motion, otherwise we cannot do this problem. So distance in the fourth second is a into 4 minus 1 by 2, which is 8 minus 1, 7 by 2a. And the third second, that will be S3, a into 3 minus 1 by 2, which is equal to 5 by 2a. Take the ratio, this will become 7 by 5, which is the option. Option is A. Here we are into the last question of the session, and in which it is given like A starts from rest with an acceleration of a1. After 2 seconds, another body B starts from rest with an acceleration a2. That means both are starting from rest. So we can use the equation S is equal to a into n minus 1 by 2 like we have done for the previous problem, because u is 0 for both. Question is, if they travel equal distances in the fifth second after the start of A, then the ratio a1 is to a2 is option A is 5 is to 9, B is 5 is to 7, C is 9 is to 5 and D is 9 is to 7. We will write it for A as well as B. For A, what I can write is distance in the fifth second can be written as a1 is its acceleration, which is given a1. It is starting from rest, so u is 0. So 5 minus 1 by 2, this becomes 2 into 5 minus 1, that is 10 minus 1, it is 9 by 2a1. And what about B? For B, the B is actually starting 2 seconds after the A started. I mean, it is starting after 2 seconds than A. So the time when it is 5, the time for B will be 3. That means the third second. For this it is fifth second and for B it will be the third second. So we are finding out motion at 3 seconds. That is equal to A2 times 3 minus 1 by 2. That is clear? So we will work out 6 minus 1, that's 5 by 2 A2. We got S5 and S3, and it is given that they are equal. That means S5 of A is equal to S3 of B. So we can equate that. S5 of A is equal to S3 of B. That is 9 by 2 A1 is equal to 5 by 2 A2. 2 cancels. A1 by A2 is 5 by 9. Ratio is 5 is to 9. That is the problem. Okay. So that's the way we do the problems which are related to, say, nth second or average velocity or stopping distance. We will be seeing more questions of related to equations of motion in the next session. Thank you all for watching the session of questions on equations of motion related to crash. Thank you very much, and I want all of you to follow the next session so that you can see much better or level questions. Thank you.